So let's start. My name's Wright. I'm a technology architect with InterSystems. I've been with the company 16, 17 years now in a variety of roles. So I'm currently in the technology architect group. Our remit is to make sure that applications built with our technology, that's applications we build and applications you build, can be deployed in performant, reliable, and scalable architectures. And one of those architectures that we see more and more now is the cloud. So that's what this session is about. Now, before we start, let me ask you a question. How many of you work for organizations that either deploy in the cloud today or thinking about deploying in the cloud in the next year or so? Okay, so probably about half of you. It's not too surprising. Cloud now is ubiquitous. Everybody knows about the cloud, or everybody thinks they know about the cloud. I don't know if any of you happened to catch the US Men's Open tennis final on Sunday afternoon. Great to see Rafa Nadal win again. But key point I want to make: during that game, IBM were running adverts for their cloud service. Prime-time sporting event on a Sunday afternoon, and IBM are spending a lot of money advertising their cloud service. So they obviously think that demographic knows about the cloud and cares about the cloud. So a lot of people are familiar with the cloud, but not a lot of people really understand what it is, how it works. People in the street have this perception of what the cloud is, and it's just that somewhere other. It's somewhere that computing happens that they don't need to care about. So what we'll do today is look at what the cloud really is. So we'll start off by considering what the cloud is, and then we'll talk about the different things you need to consider if you're going to move to the cloud. We'll do that on 3 parameters. We'll talk about what the business, what the skill set drivers might be, and then what type of application you can move or build to the cloud. So the agenda is going to look something like this. We're going to start off by talking about what the cloud is. We're then going to look at the business basics. I'm going to talk briefly about the skill set you're going to need in order to start using the cloud effectively. And then we're going to look a little bit at the type of application you can move to the cloud and what the effect on that is. So let's start off by thinking about what the cloud is. The best way to think of the cloud is not as a place, which is what a lot of people tend to think of it as, but as a set of characteristics, a set of things that the cloud can do, how it can do that. Okay, so the characteristics, how it can do that, how that cloud service can be provided to you, and then finally, the way you can deploy in the cloud, the different things you can do to take advantage of that service. I'd love to say I came up with this classification, this way of defining the cloud myself. Behind the curve here, though, because this is actually the industry standard way of thinking about it, and it was based on this paper, which is freely available on the internet should you choose to read it, authored by the National Institute of Standards and Technology in Washington in 2011. So this really kind of drew the line, set the benchmark, and framed thinking about defining the cloud, defining how to move to the cloud, and we've been using it since. It's a de facto standard. Everybody refers to this paper. I've never met anybody who's actually read it. It's one of those things. It's like all these papers. Everybody knows somebody who's read it, or they've read an extract of it, but be the first. Go read it. Okay, so let's talk first about cloud characteristics. The NIST model, defined in that paper, really has a checklist, has 5 things that identify a cloud application, a cloud-based application, or something running in the cloud. First of those is on-demand self-service. This is a key differentiator for the cloud. We'll look at that. Secondly, broad network access. Thirdly, resource pooling. Fourthly, rapid elasticity. And lastly, measured service. So let's look at each one of those in turn, talk a little bit. On-demand self-service is a real key differentiator for the cloud. What that means is that the person consuming the cloud resource, a user, a system administrator, whoever, can request resources typically compute, storage, network, but there are lots of other resources available in the cloud, as we'll mention later. Typically online through a management portal, and have them available immediately. So you tell the cloud provider what you want, and it's just there. All you need is an internet browser. Importantly, you request, you can start for them. Okay. What that means is that there's no need for that lead time of ordering hardware, racking and stacking it in your data center when it arrives, cabling, patching, setup, none of that. Okay, you go in, you tell the cloud provider what you want, and it's there and available to you. Just as an example, these are taken from the Amazon AWS management portal. This is kind of the landing page. These are the wizard-driven ways of building a simple cloud solution, kind of templates for starting things up, building a virtual machine, building a web app, starting a development project, and so on. So it's very easy to log on and start doing this. If you don't have, if you have a Google account, you can use that, or no, you need an Amazon account to log into this. I'd encourage you just to log in and a real eye-opener in terms of services that are offered in the cloud and how they're offered. So that's your wizard-driven approach. Sitting behind that is obviously a more detailed, more specific list of things you can request. And as you can see, this is just a top-level view into that. Behind this, there are a couple of thousand discrete services that you can purchase in the Amazon cloud, in the Amazon AWS cloud, and it's the same in the other cloud providers. As you can see, all sorts of different things, all sorts of specialized applications that you can purchase, provision, and have available to you almost immediately. So that's our first differentiator, our first characteristic of the cloud. Next up is broad network access. This isn't really a differentiator. This is listed as one of the things that defines a cloud application, make a cloud application different from a regular application running in your data set. What it means is that we're taking our cloud providers' resources, we're delivering them over standard mechanisms, we're promoting usage by all sorts of thin and thick clients, and we're consuming those resources on a variety of devices. So I've got my laptop, my cell phone, I can access cloud resources, your tablet, and so on and so on and so on. So that's how cloud resources get consumed. Third characteristic is resource pooling. So what's happening here is that the cloud provider has a certain amount of physical resource that they'll package and repackage based on demand for their users. So they're pooling their resources together. It's a multi-tenant model typically. So unless you specifically request and pay for it, you're not getting dedicated resource in the cloud. You're one tenant in a multi-tenant model, and your resources will be swapped in and swapped out as demand increases and falls, and you request more or you drop back. This is obviously from the cloud service provider's perspective, a key element of their business process or their business model. Okay, this ability, it's kind of like you virtualizing on hardware to get the most out of it. They're resource pooling on their hardware, again through virtualization, to get the most out of that. So it's a key part of what they do. Fourth is rapid elasticity, or if you want to use the more correct technical term, scalable provisioning. Rapid elasticity is the ability to adapt to workload changes in real time. So you can add and subtract resources as needed. You can manage that in a couple of different ways. You can do it automatically, or you can do it, you can manage that yourself. So you can say, my servers are getting busy, my storage is getting full, I'll log back into the portal, I'll add another VM, or I'll extend my storage pool, or I'll add some network bandwidth, or you can do it based on thresholds and triggers, which is really the way you want to be going within your cloud service provider's definition of your set of resources. So you can say when my CPU usage reaches 70%, either make the VM bigger or add another one. You can say when my storage is 90% full, extend it by another 50 gigabytes or whatever it is. So you can do that in a couple of different ways. Why might you want to do that? Well, it's because you can't predict the way your resource is going to be required to scale. So it could be that you're in a business where you have seasonal peaks, more orders at Christmas, more pizzas on Super Bowl Sunday, that kind of thing. It could even be in a more traditional application that you've got a busy time during the day when you need more resource, more web servers to service more interactive users and that kind of thing. You ramp them up in the morning, you drop them down in the afternoon. Be aware. People look at this and say, well, that's great, that's going to save me a lot of money, I'm only paying for resources when I need them. And potentially, yes, be aware though that it can also cost you a lot of money, because unless you manage that properly, the resource allocation will stay at the high watermark and you continue to pay for it even though you're not actually using it. So you've got to be very aware that if you're using elastic provisioning, you need to manage down as well as up. If you scale up to, you're running a benchmark, I'm running a benchmark, I scale it up to 5 VMs, get to the end of Friday, it's all good. I leave them there all weekend, not good. That's Monday morning, or next accounting period, you get a call from your manager asking to explain why the company credit card bill has gone up by $10,000 to pay for the servers you provisioned and didn't use. So you have to manage down as well as up. Okay. The last characteristic is measured service. So in the cloud, the resources you consume are monitored and metered, and you're charged accordingly. It's a very flexible model. But what tends to happen is that basic resources that don't have guaranteed performance or guaranteed availability tend to be very cheap. But then as you're requesting more availability, higher performance, guaranteed availability, and higher performance, the price tends to increase. So you need to decide what level you need to provide resource, or you need to consume resources at, and set that accordingly. Because we said commodity is cheap, specialized is more expensive. Any questions about any of those characteristics before I move on to cloud service models? Okay, moving swiftly along then. What we're talking about now is the way that those cloud service providers can deliver resources to you. There are 3 models. Again, this is all part of the NIST definition, and as usual with things IT, it's acronym driven, so we'll go through the acronyms and what's behind them. And we'll start really from the lowest level, the right-hand side here of the cloud provision stack. So first up is infrastructure as a service, or IaaS, which is where what you're getting from the cloud is just kit, okay? And this is typically the entry point for people who are moving into the cloud with an existing application. You've currently got it running on servers with storage and network in your data center or in your colo, and you just want to get out the business of managing that. So you move that resource into the cloud and pay on a fee-for-service basis, on a metered basis, the cloud service provider to take care of that for you. So that's infrastructure as a service, where you're getting, they're providing the data center, they're providing the rack servers, they're providing the storage, but you're managing everything on top of that. Next up is platform as a service, which builds on top of infrastructure as a service, acronyms PaaS. And in this, really what's happening here is that the cloud service provider is not just giving you the hardware, not just giving you the infrastructure, they're giving you a complete environment. So all you need to do is think about developing, testing, and deploying. They're going to take care of everything that's running underneath that. So it's encapsulating all of the underlying infrastructure, management, and so on. The outermost layer is software as a service, SaaS. This is where you consume a software service that's running in the cloud, and you pay for it as you consume it. You can pay for it in a couple of different ways. If this is what I might term a consumer service, like Gmail or Facebook or something like that, then you're paying for it through advertising. You're looking at the adverts that scroll up when you use these things. If it's a corporate service, and these are things like Office 365, Workday, Salesforce.com, these kind of things, then you're going to pay a subscription fee, or a company-wide subscription fee to use these things. The last one, if anybody ever does go and read that document and find something in there that, oh, sorry, let me go on. So, backtrack on that, I missed something. So those three together are part of the SPI, are part of the NIST definition. They're referred to collectively as the SPI model. So they take the definition from the other way up, and that's what you found in that NIST definition. That was written in 2011, right? So quite a lot has changed, well, an awful lot has changed since then, okay? In the past 6 years, as we've seen now, there are 2,000 and counting different things you can purchase in Amazon AWS, and it's the same with the other cloud providers. So we have another group of services now that are referred to generically as XaaS, or anything as a service. Within that, there are other things broken down. So you've got containers as a service, DR as a service, monitoring as a service, network as a service, and so on and so on and so on. The only limiting factor there being the number of acronyms people can think up that end AAS to specify what they've already got. I can see we're going to get 3- and 4-letter lead-ins before very soon. But this is a really fast-growing area. Things like DR as a service are really taking off now. So any questions about that? Cool. Okay. The last part of the NIST piece is cloud deployment models, the different ways you can make those available or they can be made available to the public. First one is the one that the guy using, his cell phone to look at Instagram is familiar with or thinks he's familiar with, and that's public cloud. Okay, so this is where that model where the resources are multi-tenant, they're shared, and they're available to you in the public. The big three are Amazon AWS, Microsoft Azure, Google Cloud Platform. It's really the big one. Amazon AWS is about 6 times larger than all the others put together. Off the side of this diagram, there are another, however many you want to count, niche cloud providers who have a specific offering, typically targeted at a specific vertical in the market. But they're the big three. When I use examples later on, I'll use them taken from AWS, just because it's the one that most people are going to be more familiar with. Next up is private cloud. This is one that differs from public cloud in that it's dedicated resource. It's a single consumer on a private network. It doesn't dictate where the resources are located specifically. It just says that they're dedicated to you. So you can own and manage those resources yourself in your own data center, but make them available in a cloud-like manner. You tick all those 5 characteristics. You've got a cloud base, a private cloud that you're making available, or they can be another provider's resources that are dedicated solely for your use. And of course, going back to what we said earlier, dedicated to your use means it's going to cost you more money. Okay. The next one is hybrid cloud. I don't think you have to be too versed in the cloud model to guess what this is. This is the bringing together of private and public cloud. This is the one that's really growing the fastest at the moment. This is the idea that you can take your private cloud resource typically and expand it seamlessly. So you can take your private cloud resource, expand it into the public cloud, and then contract it back into the private cloud. Seamlessly, it will grow, it will contract. Why might you want to do that? You might want to do that, again, in demand, in response to demand. So you size for 9 months of the year, or if you're Domino's, you size for 364 days of the year. On Super Bowl Sunday, you expand out into the public cloud, consume those resources you need when everybody's phoning in for pizza, and then contract back the next day when all those orders have been processed. Okay. I say this is the key thing here is that seamless movement. If you want a proper hybrid cloud, you have to be able to migrate in. It's like the tide going in and out. You have to be able to do it without sort of shivvying it along. Okay. If you do go back and read that NIST document, you will find that there's a 4th category of cloud deployment model here. I'm a completist by nature, and I don't want you emailing me in a few months' time saying, I read that document, there's something in there you didn't mention. There's a definition there of something called community cloud. Community cloud is a specific set of resources that are shared by a set of organisations that have common interests, and these common interests are typically around data security and data governance. So there aren't many examples of this that I know of, we work with. We do in the UK have a healthcare specific cloud. Doesn't have a lot of adoption yet, but it is there, and that takes care of the specific access protocols you need to go through to get access over the NHS private network in the UK into a cloud-based environment. In the US here, there's something called GovCloud, which is a subset of AWS, which is specific to government cloud-based applications. But that's the fourth one for anyone going back and ticking all the boxes in that document. So, any questions? Okay, so moving right along, let's talk briefly about the business drivers for moving to the cloud. The first one is agility. Okay, so to net it out and not get into a long discussion about this, cloud computing is an agile methodology, or it is based on agile methodologies. It's DevOps based. Cloud computing tends to promote a software development cycle that is quick, that's efficient, that's agile. Software agility drives business agility drives the bottom line. The other reason for going to the cloud is cost, direct and indirect cost. The direct cost you're saving, or potentially saving, the direct cost you're not incurring is infrastructure and staff. You're not paying for all those servers up front and amortizing them over the lifetime, 5 years or whatever. You're not paying for the staff who are putting them in your data center, cabling them up and dealing with them. The other type of cost is indirect cost, so the cost of downtime and those kind of things. So those are the costs involved. You're going to be shifting, if you move to the cloud, from a primarily CapEx model, where it's capital cost, to an OpEx model, where it's operating cost. So instead of paying for things up front, you're going to be paying for them as you use them. The one thing I'm going to say here is that don't assume you're going to save money by moving to the cloud. You may save money, or it may cost you money. Okay? You have to be very specific about what resource you need, how long you need it for, what levels of availability and performance you need. You have to cost that very carefully and compare that to the cost of running that on-premise or having it hosted or something like that, because moving to the cloud is not a shortcut to saving money. Okay? You have to be aware of all the costs. It's very, if you just log on to the AWS portal, you can have a free VM up and running in 10 minutes. You think, great, we can run the business like this. Doesn't work like that. Okay? So you have to be aware of all the costs. But let's assume that you've done your figures, you've done your numbers, you've worked through your different cloud providers' cost structures, and you've figured out that, yeah, it's either going to be cost effective or cost efficient in that the benefits I'm going to get are worth the extra cost. What skills do you need? Well, you don't have to do much thinking or reading about the cloud to come across the term DevOps. The cloud and DevOps are kind of married together very, very closely. DevOps, what is DevOps? DevOps is the idea that you're going to have a seamless, continuous integration of your software development, testing and deployment life cycle, and it's going to feed back into itself. So this is infrastructure as code, this is pushing things through automatically, this is deploying them, this is shortening the life cycle, feeding that back into development, obviously based on agile technologies. But if you're really going to embrace this, you're going to need a tool-driven approach. The DevOps tools that you'll hear mentioned are going to start with the tools that automate the process of pushing those resources around, those artifacts around. So you develop something, how do you move it on to the next stage? Okay. How do you move it into production? And how do you move it back into your development environment? So these are the tools you're typically going to start with, the tools that enable that to happen. So things like Docker, Chef, Puppet, Ansible, Salt, Kubernetes, and so on and so on and so on. You'll have heard these mentioned previously during the week in the discussion of InterSystems Cloud Manager. We're using Docker and Kubernetes under the covers to make that happen, but there are lots and lots of other tools out there. But if you're going to embrace this properly, those aren't the only tools you're going to need. If you're going to move to a proper DevOps tool-driven approach, you're going to need all sorts of other tools. You're going to need things like cooperation tools, things like Slack and HipChat. You're going to need integration tools like Bamboo, testing tools. You're going to need monitoring tools, things like Splunk analytics tools like that. You're going to need tracking tools like Jira. And you're going to need feedback tools like SurveyMonkey. I mean, those are just tools picked out of a whole plethora. There are thousands of them out there. And we do this internally, and we use all of those. Okay. Any questions about that? Okay, so you might be thinking, well, that sounds like a great way to develop software. Do I have to go to the cloud to do that? And of course you don't. Okay, so if you want to get into leverage that agile development methodology and take a DevOps approach to creating and deploying software, is it possible? Of course it is. You can use a DevOps approach without deploying into the cloud. The difference is that at that last point where you develop, you're then going to need some way of closing the loop. If you're not developing into the cloud, you won't have that agile DevOps-driven approach to bring that back. But in general principle, a tool-driven approach is very achievable whether you're deploying into the cloud or not. But what if you want to do it the other way? What if you think the cloud sounds like a great idea, but you don't want to streamline your development process? You're quite happy with the waterfall process you've got in place. You know, the guys like it. They've been here a while. We don't want to, you know, who needs all this new stuff? So can you do the cloud without DevOps? And again, you can. If you really want to, you can, but this is going to be much more difficult, okay? Because the cloud is really geared up to work in this model, okay? So I kind of think that the cloud and DevOps are kind of two tools. Each one is very useful on its own, but they're a lot better together. It's kind of like a knife and fork for eating your dinner. If you've got a knife, you've got a fork, you can use either one, it's great, but you know, if you use them together, you're going to get through it a lot quicker. Okay. So, any questions about that? Okay, let's talk about applications and what type of application you can move to the cloud. Well, obviously you can move any application to the cloud if you put enough effort into it. But what we're talking about here is lift and shift, you know, going from one to the other. So the classification I'm using here is Gartner's bimodal IT classification. It's fairly standard in the industry. I like to think of this as a for demonstration purposes only classification because it is, as it says, bimodal. So it's dividing applications into two kinds, which it terms reliable and agile. In reality, there aren't just two kinds of applications. There are as many kinds of applications as there are applications, and there are much more nuanced models for classifying types of applications that are available when you start thinking about, okay, where on the spectrum do I fall, and what's the workload going to be to move this into the cloud. But for the purposes of the discussion here, let's just consider the two endpoints of the spectrum. On the one side, we've got what Gartner term reliable applications. These are the ones that you've probably built in-house up until now. They tend to be focused on cost containment, cost reduction, and predictability. Predictability not just in cost, but in workload, in performance, and all those kind of things, across all sorts of parameters. They tend to be stable, and change tends to be incremental and relatively slow. So you know what you're going to do over the next 3 months, 6 months, a year, probably 2 years and out beyond that. You know how your resource requirements are going to grow. You know how performance is going to be affected by that. So it's stable, it's low change, it's incremental change, and the change cycle tends to be months or even years. So it's a release every 6 months, it's a release every year pushed into life. The other type of, a bit happy on the clicker there. The other type of application are really the cloud native applications. These are the ones that are flexible, quicker. The key point is that you don't actually know what's going to happen tomorrow, or you plan, or you don't plan. because you want to be agile enough to respond to what happens tomorrow rather than planning 6 months, a year out. So these tend to be driven much more by user requirements, and the change cycle tends to be much more rapid. Rather than months and years, it's going to be weeks, days, or even hours, and frequent. So we're not doing a once-a-year release. We're doing it daily, or we're doing it weekly, or we're doing it monthly. Okay. So since we're talking about migrating applications, let's focus first on reliable applications. So what's the use case for moving your reliable application into the cloud? As we've seen, it's probably not a good fit for a DevOps model because the change cycle, the change regime doesn't fit so well into that constant rapid loop. So why would you do it? You might want to do this, as we said before, because you want to get out of the business of managing your own infrastructure. You might want to take that and drop it onto infrastructure that's managed by someone else. So this is typically what we could term a cloud-ready application. And because it doesn't fit into that cloud-first model, you're typically going to use an IaaS type of deployment, infrastructure as a service, rather than platform or software as a service. It's feasible, it's achievable. You can do this with an application based on InterSystems technologies. But what do you need to think about? What do you need to consider before you say, yes, it's a good idea to move this application, assuming that you figured that you've got the skills and it makes sense from a business perspective? We need to be sure that performance in the cloud is going to be acceptable. You need to be sure that availability in the cloud is going to be acceptable. Big one is security. You need to be sure that the data is going to be secure once it's in the cloud. And you also need to be sure that your day 2 operations, okay, we moved it to the cloud on Monday, what happens on Tuesday? You know, how do we back it up? How do we monitor it? And those kind of things. You need to be sure that you've got an operational regime that's robust enough for your business. And then when we've done that, I'll just show you a couple of reference architectures just so you can see what that might look like in the cloud. So starting with performance, as we've said, the cloud is full of resources, but not all those cloud resources are created equal. Okay, things that are not highly performant and not highly available tend to be cheap. As you want guaranteed performance and guaranteed availability, cost increases. That's true across all 3 parameters: compute, storage, and network. In the cloud, typically, and this example is from AWS, but you know, other cloud providers are available, as they say in the UK. What you're going to do is choose from a range of templates that say these are the VMs we have available. These are the compute resources we have available. You pick one of those. In AWS, that's termed an AMI, a machine image, and then from that you instantiate the particular VM you want, or the VMs that you want. Those VMs, as I've said, come in a range of performance points. So you can add more CPU, you can add more memory, and those kind of things. And they're also specialized VMs. So if you're doing something like image processing, say, and you want a specific type of VM, you can pick that too. So again, the bigger it is, the more highly performant it is, the more money it's going to cost you. Very similar story with storage, again, taken from AWS. Basically, what you're paying for here is provisioned IOPS, okay? The speed at which you're going to get storage on and off, or in and out, or data in and out of storage. So from the lowest cost down here, Glacier, I mean, I think you can guess from the name what kind of storage they're pitching that as, up to the other types of storage, which are going to be the type of thing you want for production. Typically, if you're doing production in the production environments in the cloud, you want all flash, so you're looking at the top end of the storage, certainly for your production environments. Network in the cloud. You no longer control the network. So it's inside your virtual private cloud, the thing you build, okay? So in order for you to manage that network, these are some of the things you're going to have to think about. You're going to have to think about network security. You're going to have to think about distributing things amongst the different resources you have using load balancing. You're going to have to think about your IP address management. okay? You're no longer just sitting there controlling your IP addresses, so you need to think about what scheme you're going to use for that. And then you're going to think about, how do I get into and out of that? Okay? How do I connect from the outside world into my virtual private cloud? How do I connect from that back out to the outside world? So you need to think about the different gateways and the different ways you can do that. Okay? So once you've figured out that you can build something that's as performant as you need, you also need to make sure it's going to be as available as you need. The cost of downtime obviously is significant. If you can't run your business doesn't work, that's a big cost. That's that indirect cost we talked about earlier. When you start looking into the cloud, you'll see that the terminology differs slightly from provider to provider, but basically it's built around the concept of availability zones and regions. An availability zone you can think of, and normally is, a discrete data center. So you can have availability within a zone, within a data center, and you can have availability within a region. Okay? So in this case, obviously, if you kind of equate that to the real world, you're going to think about what happens if there's failure in the data center. What happens if there's failure in the region? What do I need to do to mitigate that? And because you're not controlling those resources, you have to assume, and this should be a key design principle when you start putting your architecture together, you have to assume that everything will fail at some point. Okay? That's the way to architect for the cloud. Assume there's going to be failure. Don't try and prevent it, which is typically what you do in the data center. Figure out how you're going to mitigate it. What can you do to deal with that failure, not if it happens, but when it happens. So, obviously in this context, our mirroring technology is going to be a really useful tool for keeping multiple copies of data, both within a region, so between data centers, and then from region to region. Why would you want to do that? Well, ask all those companies that were affected by the outage of the US East 1 region from AWS in March of this year. So that failed in March of this year, and an awful lot of companies that should have known better were affected by that. So companies like Trello, MailChimp, Slack, Expedia were all offline for as long as that AWS region was offline. In fact, even Amazon themselves were affected by that. The other thing you might want to consider is not just region-to-region availability, but cloud-to-cloud availability. We're seeing this more and more now. People are deploying in, say, Azure, but they want to be protected against complete failure of the Azure cloud, so they're deploying their DR in another cloud provider like Google Cloud Platform or AWS. Okay? So there's lots of different availability regimes. And obviously the differentiator here is cost. So, you know, the more highly available you want to make the system, typically the more money it's going to cost you. It's no different in the cloud from it is in your own data center. Okay.
So there is a cost to moving that data.
Yes. 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 Yes.
Why those companies are all in zone 1?
Yes. Well, there's a couple of reasons. One is the cost, and two, it's quite difficult to figure it out. It's much easier just to say, it'll be all right. But yeah, the cost, and typically the greater the degree of separation between the copies of your data, the more money it's going to cost you. The most expensive one is cloud to cloud. Yeah. But no, it's an excellent point. It's expensive, and it kind of needs a lot of thinking about. So it's much easier just to say, don't worry, Google will take care of it, or Amazon will take care of it. But you have to assume everything's going to fail. Okay, so let's assume for the moment when we talk about security that your application has a robust security protocol. You've taken care of things like authentication and those kind of things in your application. What else do you need to think about when you move off-premise and into the cloud? Well, I'd suggest that encryption is no longer optional. You don't control that data, you don't really know where it is, so it would behoove you to encrypt all your data at rest, I think. And that's not just your .dat files, it's everything at rest. So it's your journal files, it's any other ancillary data that you have. as part of your application. Use proper encryption for doing that. You also no longer control the network traffic. So you have to assume that that can be compromised as well. So you're going to want to use encryption for all your network traffic. And that's not just, to use the current industry buzz phrase, north-south traffic into and out of the cloud. It's the east-west traffic. It's the traffic between your servers. If you're doing this inside your data center, you could reasonably assume that you can control that and that you don't need to encrypt that. If you're deploying in the cloud, you should. There's no probably about it. You should, because you have to assume that if you don't control it, it can be compromised. Obviously, you're going to need robust key management policies and procedures to support all that. But if you take care of all that, that's Security 101. The elephant in the room is data governance. There are all sorts of rules and regulations about what data you can store in the cloud and what you can do with it once it's there. These rules vary from country to country. They vary from state to state. And you may even have company rules. So, if your company uses cloud-based applications, it's okay to have email there. But it's probably not okay to have company confidential information there. In Europe, there are some very, very strict rules about what patient identifiable data can be stored in the cloud at the European level, and then countries themselves layer on top of that more rules. So in the UK, it's fairly flexible. In Sweden, for example, Finland, for example, there's just a blanket ban. You can't do it. So data governance, it's very important to look at the data governance requirements before you do all that other work, because this could stop it before you go anywhere. Okay? We talk to a lot of people who are considering moving to the cloud. And for those people who decide not to do it, data governance concerns are the number one reason. I need to speed up because we're running out of time, so we'll talk briefly about operations. It's no good assuming that we'll move to the cloud, as I say, on Monday and it's all good. You have to be on a variety of levels probably, but you have to be sure that you can take care of your application once it's there. So you need to do backups. Whichever way you do them, and there are various ways of doing them, the cloud providers will give you backup tools, or you can install a backup agent, take a backup in a more traditional way. Whichever way you do them, you have to make sure that you're calling freeze and thaw, just the same as if you're doing a backup in your data center. You have to make sure that you run integrity to ensure that the backups are clean and consistent. Just because it's in the cloud doesn't make it any less onerous to back up your data. You also have to decide what you're going to do with it, with your backup, once you've taken it. It's very tempting to think that, out there in the Amazon data center, there's a tape library and a guy, running around shuffling tapes in. Doesn't happen. There's no tape support in the cloud. So you have to put your backup data somewhere that meets your retention and availability requirements. That's where you're going to drop down typically to the lower levels of storage availability, or storage cost and availability, and use long-term, low-cost storage for long-term retention rather than tape. Okay. Any questions about any of that? So, we decided it's a good idea. Have we done this before? Yes, we have. Can we help you do it? Yes, we can. We have reference architectures for popular cloud providers for all of our products. So if you're interested in doing this, go to the developer community and you can find these architectures. I will say now that these are you're not going to be able to take one of these and say, yep, that works, and copy it all across, because this is a generic reference architecture. When you come to define what you need to move to the cloud, talk to your sales engineer, talk to us in the technology architect group, and we'll be able to figure out specifically what you need. These are meant to be a guide, a starter for the kind of things you're going to need to be looking at. Okay, so I'll say on the developer community, we have one for AWS, and we have one for Azure, and compare and contrast. We're working on one for Google Cloud Platform as well. view them as what they are, a starting point, a map to get you to somewhere, not something you can take and say, log on to. What you don't want to do is take that, log on to the AWS portal, provision all that and say, yep, I'm good now. You've really got to think about it in detail, about what you need, how you need it, how you're going to build it. So just to finish off, what if you're deciding to build a net new application? What if you're starting over and you're building what we term a cloud-first application? Well, it shouldn't be any surprise to you that we now have a tool that does that. InterSystems Iris Data Platform is just that tool. It's cloud-first. It's built around a DevOps model. It includes the InterSystems Cloud Manager, which is the tool for provisioning those machines in the cloud. It leverages the tools that we talked about. It leverages Docker and Kubernetes under the covers. And it's cloud agnostic. Okay, so it doesn't matter whether you're installing in a public cloud, private cloud, hybrid cloud, whether it's Google, whether it's Microsoft, whether it's Amazon, whether it's one of those other niche cloud providers. So all sounds good. What do we want? How can we sum that up? So if you've built an application on our technologies, can you deploy it in the cloud? Yes, you can. Reference architectures are available. We've done this before. Talk to us, talk to your sales engineer, talk to the technology architects, and we'll figure out exactly how you can do it, because you don't want to just take a generic solution. If you're building net new, look at InterSystems Iris Data Platform. It's cloud first. It will give you the tools you need to build that DevOps-enabled, cloud-ready, cloud-first application. But what if you're sitting there thinking, geez, that sounds difficult. I'm not going to do that. And you want to stay on-premise, well, don't worry. We're very committed to ongoing commitment. We've got this ongoing commitment to on-premise deployment if you decide cloud is not in your plans. At the moment, if I'm honest, if our total deployments around the world are that big, the cloud ones are that big. Do I expect that to grow? Yes, I do expect it to grow. Do I expect it to get to here? No, I don't. There's going to be a lot of on-premise deployment for a long time to come. We're very committed to supporting that. So, again, talk to us about what sort of architecture you need. So, where to go from here? While you're here, if you've got any questions, come and talk to me, or talk to one of the other technology architects, Mark Belinsky, Murray Oldfield, Tony Pepper. We're all around for the rest of the day. I would suggest, or I would have suggested using the Experience Lab for the hands-on session about using Iris and deploying in the cloud. Not because it's only applicable to net new, but it gives you a feel for how the whole mechanism works and what the cloud interaction is going to be like. And when you've left here, contact your sales engineer, contact us. If your sales engineer doesn't know, he'll contact us. And if you just want to learn about the technology, obviously we've got the online learning, we've got classroom training, we've got the documents. The one I'd really suggest you look at is this one, the developer community, because it's kind of a DevOps model for getting out information to people. It's a lot quicker and it takes feedback. So now, we develop stuff, we develop blog posts, we develop things like those reference architectures. They go onto the community. We get feedback from customers, we improve them, we change them, we comment on them. So that really should be your first place to look, and that's immediate. Okay, we'll respond to that immediately. It doesn't need that whole release process cycle to go around. So in conclusion, I'll just say thank you. Thank you for coming along to the conference. Hope you enjoy the limited rest of the time you have here. And I hope to see you all again next year. Thanks very much.